Atoms sticking together explains structure, but it doesn't explain change. The world around you is constantly transforming. Fuel burns, food cooks, iron rusts, and living cells produce energy every second. All of these changes happen because chemical bonds don't just exist, they break, form, and rearrange. And that process is what we call a chemical reaction. This is the Learning Studio, where chemistry is explained as a chain of causes and effects rather than isolated facts. And now that we understand why atoms form bonds, the next logical step is to understand what happens when those bonds change. Because chemistry truly comes alive when matter transforms. Most people think chemical reactions are just equations written on paper, but in reality, they describe real atomic events happening everywhere around you. For example, when wood burns, it may look like matter is disappearing into flame and smoke. What's actually happening is far more precise. Atoms in the wood are breaking old bonds and forming new bonds with oxygen in the air, releasing energy as heat and light. Nothing is destroyed. The atoms are simply rearranged into new substances. At the atomic level, the mechanism is straightforward. Chemical reactions occur when atoms collide with enough energy and the correct orientation to break existing bonds and form new ones. Breaking bonds requires energy, while forming bonds releases energy, so every reaction is an energy balancing process. Whether a reaction happens quickly, slowly, or not at all depends on how difficult it is to overcome this energy barrier. This idea became clear through the work of Svante Arrhenius, who introduced the concept of activation energy, the minimum energy required for a reaction to begin. His work explained why heating speeds up reactions, why some reactions need sparks or enzymes, and why others never occur under normal conditions. With this insight, reactions were no longer mysterious events, they became predictable processes. As chemistry developed, scientists learned that reaction speed and outcome depend on factors such as temperature, concentration, pressure, and catalysts. This understanding transformed chemistry into a controllable science. Instead of discovering reactions by accident, chemists could now design reaction pathways, control yields, and optimize efficiency, a shift that made large-scale industry, pharmaceuticals, and modern materials possible. Once chemical reactions are understood this way, their importance becomes impossible to ignore. Every battery works because of controlled chemical reactions. Every medicine is created through carefully engineered reaction steps. Life itself depends on millions of chemical reactions happening every second inside cells, all precisely regulated to sustain existence. And once we understand chemicals transform matter, a deeper question naturally follows. If reactions involve energy changes, then why do some reactions release heat while others absorb it? That question takes us directly into the next episode, where we explore energy in chemistry and why reactions are exothermic or endothermic, the concept that connects chemistry to thermodynamics.